Okay, so today's notes are on linear functions in slope-intercept form. Our content objective is to graph linear equations and write equations of lines, and our language objective is to use the correct terminology to describe lines and their equations. So hopefully a fair amount of this will be review for you, but in case not, we're going to go through the details. So slope is the ratio of the vertical change to the corresponding horizontal change. So if you don't recall, this is just rise over run, so it's how much it goes up and down, vertical, over how much it goes left and right, horizontal. So just a quick visual. We have our X and Y axes, and we have a line going up like that. We'll label this X1, comma Y1. So that's a point there, and then we'll call this X2, comma Y2. Another coordinate point, the slope is going to be the vertical change, or the rise, which is this component, so how much is going up, to the horizontal change, or the run, which is this component. And so slope is just rise over run. So our slope, which we will use the variable m for slope throughout this unit. So if you ever see lowercase m, that just means slope. So slope m is equal to rise over run, or it's equal to the change in y over the change in x. So y2 minus y1 over x2 minus x1. So this is the slope formula you'll see for the rest of this set of notes at least, and throughout this unit. One thing I want to note is that x2 minus x1, sorry, I forgot the one on that, cannot ever be equal to 0 because you are never, ever, ever allowed to divide by 0. So you could never have that equal to 0. You'd end up with an undefined slope. We can talk more about that later, but for now, I want to move on to an example of finding slope. So I want us to find the slope of the line that goes through the points -3, 7 and -2, 4. So what we're going to do here first, if it's helpful, we can label our points. When I say label, I mean write x1, y1, x2, y2. So in case you've forgotten, when you write a coordinate point, x always goes first, y always goes second. So when I'm labeling these, 1 and 1 always go together, 2 and 2 always go together. So then I'm going to substitute. So y2 is 4 minus y1 is 7 over x2 is -2 minus x1 is -3. So notice it's minus a negative. So I end up 4 minus 7 is -3. -2 minus -3, the double negative becomes a plus. So I have -2 plus 3. So I have -3 over +1, which is just -3. So my m value is equal to -3. The last step I did was simplify. So I've now successfully solved for my slope, -3. So just a quick little thing to make sure you're understanding what we're doing here. I want us to interpret this together. So if we just got a slope of -3, that means that the line goes down 3, or 3 units, I should say, for every 1 unit that it goes to the right. So that means I went down 1, 2, 3 over 1. So down 3 over 1, and that is my slope. In case that's helpful for you interpreting. it goes down 3 over 1 to the right. All right, I'm going to flip the page and go over some different types of slope. So while I do that, if you can send me a quick email to kleary@k12.centerville.ma.us and let me know you're listening, that would be great. So send me an email right now. I'm going to jump into some other kinds of slopes. So we have positive slope, negative slope, and zero slope. We're going to start with these three, and then I have a few other ones. So positive, negative, and zero slope. Positive slope, if I have my y and x axes, it just goes up from left to right. Negative slope will obviously be the opposite. So again, x, y axes, but this time it's going, that's a y. It's going down from left to right. So you read slopes the same way you read words, from left to right. So up left to right is positive, down left to right is negative. Zero slope is when we have a horizontal line. So it's just going to be y equals a number. So again, this is our x-axis, our y-axis. A zero slope is just a flat line. So that's just y equals something, or y equals a constant. That's a zero slope, a flat line. We also can have an undefined slope. So if you remember just a second ago, I mentioned that we can never divide by zero. If you do end up with a slope where you have zero in the denominator, the resulting line would just be a vertical line. It'd be x equals numbers. This is y equals a number. This would be x equals a number because it's a horizontal or vertical line. We were talking about those the other day. So undefined slope is just a vertical line. I'm going to mention two other, not types of slopes, but parallel slopes and perpendicular. And we're going to spend more time with these tomorrow or in our next set of notes. So perpendicular slope, I didn't quite have room to write that all there. But if I have parallel slopes, again, x and y axes, all that means is that my slopes are the same. So M1 and M2 are equal. M1 equals M2. So parallel slopes have the same slope, whereas perpendicular slopes actually intersect at a 90-degree angle and are negative reciprocals. So perpendicular slopes, again, we'll talk about these more tomorrow, but their slopes are negative reciprocals. So M1 equals negative 1 over M2. So this is M1, M2. So we'll talk more about that tomorrow, but just to introduce those types of slopes so you've seen them more recently. All right, the last thing I want to talk about is the first form we're going to work with, slope-intercept form. So slope-intercept form of a line is just y equals mx plus b. M is our slope, b is our y-intercept. So you've probably seen this before. So when we have slope-intercept, it's y equals mx plus b, m is our slope, b is our y-intercept. So I want to talk about one example really quickly before you try out classwork stuff on your own. So our example I want to do together is, what is the equation of the line with a slope of 1 over 5 and a y-intercept of 0, -3. And I want us to write this in slope-intercept form. So the first step we're going to do is determine m and b. And you probably already know these because you've seen this before, but m, we know it represents our slope, so it's going to be 1 over 5. B is our y-intercept, so it's the y-coordinate of the y-intercept, obviously, because x will always be 0 at our y-intercept. So b is -3. So I'm just going to substitute into slope-intercept form. So I have y equals 1/5 x, and it'd technically be plus -3, but I can rewrite this as 1/5 x minus 3. If you didn't write plus negative and just jump to this step, that's fine as well. But that's all we have to do there, substitute and simplify, and we have our slope-intercept form. So that's all for today's notes. Make sure you write down any questions, comments, or concerns you have so we can go over them together.